Hello, in today's session we will have an introduction to Nurbs and curves in Maya. So when you go to create, the first menu will be for Nurbs, and in this section the last one will be for the curves. So when we are working with Nurbs, we are going to work with curves parallelly, so they are going to be in tandem, where we are going to create things using curves, and from Nurbs we will convert it into polygon. So the reason we are not using Nurbs from 0 to 100 or till the rendering or animation is when we get into unwrapping, rigging, those areas, controlling polygon is more comfortable than Nurbs. So when we are sitting in a pipeline, as we saw in the first video, so there are many people going to work in the model which we are going to create. So the model should be flexible for everyone in the pipeline. So but that doesn't mean Nurbs are not useful. So the full form for Nurbs is non-uniform rational B-splines. So here in the curves we have different types of curves. So when we are getting into curves, we will see each and every type and their differences. So when we see the Nurbs, as we saw already, the base is entirely different for Nurbs and polygon. Here also we can see the same sphere, cube, cylinder, cone, plane, torus. Those things are going to be here as well as in polygon, but their base or their components are entirely different. The way they got built is also different, but when we see visually over here, we couldn't find any difference. But in this polycount we can see the difference. When I click the Nurb surface, I won't be able to see any words, edges, face or tries, but when I go and click polygon, I see numbers over here depending on the number of components it contains. But again, when I see this cube, Nurbs cube, the faces are going to be separate, but in a polygonal cube, here we can see the components are intact. Again, when I right click, I see vertex, edge, object and face for these polygon components, but when I right click Nurbs object, I can see control vertex, isopalm, object mode, hull and surface point, surface patch, these things. So the base is entirely different. This Nurbs uses a different technique when it renders, like when the camera is near, tessellation method where the triangles are high, and when the camera is far away, it will give you less triangles. This tessellation method is not available in polygon, but in other ways polygons are more comfortable when we are working for movies, games, VFX, where there is a pipeline, dynamics is involved, rigging, animation, those things are involved. So better we go with polygon. Again, when we are working with Nurbs over here, we are going to modify this into Nurbs to polygon when we are working. Mostly we won't carry Nurb surfaces beyond unwrapping or texturing, so it will be converted into polygons. When we are converting and working, we will see how to convert Nurbs to polygon, because there are so many options. We have to spend some more time over here. So then why we are getting into Nurbs, why don't we do the same thing in polygons? When we are the Nurbs, the main thing is in Nurbs the curved surfaces. We want curved areas. We better go with Nurbs and then convert into polygon rather than modeling the same thing in polygon. When we are working with Nurbs, you will understand the difference between doing a smooth surface in Nurbs as well as in polygon. For example, a car's body or a bonnet or something like a bulb or vase, those things are more quick and easy in Nurbs compared to polygons. When the Nurbs get created, by default it is going to be in smooth mode. Number 3, when I press 1, I can see the default mode. By default, when it is getting created, it is going to be in the smooth mode, but this is going to be opposite in, they are going to be default mode when they are getting created. So when I right click, I see here control vertex, isopalm, hull and surface point. So when I press hull, I see a skeleton of this sphere. So this is called the hull, the something similar to a skeleton for your object. Then when I press isopalm, you see these lines, vertical or horizontal lines. These lines are called isopalms. Right click, control vertex. We see dots over here. These are called the control vertices. They are not going to be near your edge intersection. They are going to be a bit away from it, not like vertex. So this is called the control vertex. Hull, isopalm, control vertex and surface points, these are the main components of a NURBS surface. But when I create a curve, there are many types of curves. I'll just create CV curve, something called a control vertex. So here we see, right click, control vertex. Here also we have the hull, we have the control vertex. I'll go with the control vertex. So when I click the control vertex and move, I can see I can move the curve. Here also, when I right click, control vertex, move it, I can see I can move these curves or isopalms over here. So how did these NURBS start? Like earlier when people were building ships, they needed curved surfaces, so they used wood for that. So to get the curve for the wood, they had weights to get the curves happening. So that is how the basis or the physical curves were created in earlier times. Then in the drawing room, splines were created, the same curves with the weight but in smaller size. So in a computer, the first time they created in Renault company, the person who created is called Pierre Bezier. After a few years, the software was open to all the other general purpose 3D. Till Polygons, NURBS were very famous, they were very comfortable. But in our pipeline in Maya, that is NURBS is used very minimalistic because we are mainly dependent on Polygon. But there are still people who work with NURBS very well, who can create very nice character models. I think in the movie Madagascar, the characters were created using NURBS, and there were some Pixar labs testing rigs with NURBS. Those are in the lab stage, so we better go with what the common norm is in the industry, Polygons. But NURBS is very useful. Don't skip NURBS. We will see some class about NURBS and their use. More than Maya, it is used in other fields extensively. First, we will see what is this hull and what is this control vertex. When I press space bar, right click, I will go to top view. So in the top view, I have some images. I'll just delete these things. Now I have some images over here. Here I have the curve. So when I have the curve, you can see these curved wooden planks. The curve is obtained by applying weight or holding them. So this is how a ship's hull looked like, something like a skeleton of a ship. So these splines, these are the splines. You can see wooden lines with weights pushing or pulling, holding them. They are going to be iron bars which are going to be heavy. They are called ducts, and this is called the spline. So you can see visually it is being pulled in opposite direction to get the curvature. Here we can see some example. So this is the spline. The same way we have when we take our spline, we can see CV curve tool. We can see weights pulling over here. The same way we can see over here when the weights are applied in this direction. Here we are getting some similar curve like this over here by applying ducts. Here we call the control vertex. So these are the basis of curves and NURBS hulls. So when we start modeling, so it is going to start from here. When we understand these curves, then other tools will be very easy. So in our field, in Maya, we don't see much, or we don't use much of Nurbs potential, but in other softwares, in other field, it is 100%. So like parametric modeling, or in jewelry design, where a product have to be manufactured after modeling, in those fields you need perfect measurements in maybe in 0.3 decimals. There you should get an output. That output should function. So those conditions, those softwares use Nurbs 100%. For example, in jewelry design, these are the main softwares: Rhinoceros, JewelCAD, 3D Design Matrix. These are main softwares for creating jewels, ornaments. ZBrush is not a main software, like it is mainly used for sculpting. Nowadays in some companies they are using it fully to model jewelry design. So why they do jewelry design? For example, you see in an online advertisement there is a earring or a ring, so that doesn't mean they have that physical ring with them. So when you order, that model will be there, it will be printed and delivered to you. So for minute design, for very precise measurements, these softwares are used, and in these softwares Nurbs are the main form of modeling. So when we go to automobile, mechanical and other designs, here it may be a 3D printer or a small size printer to print these models. But when you go to automobile and other areas, there will be CNC machines. Through those machines you have to create those parts. Mostly it will be like revolve or extrude. 90% using these two commands you can create mechanical models. End of the day, when they go to the machine is going to do either milling or turning or making hole. The part is going to rotate or the tool is going to rotate. So these are the softwares which are used in engineering fields to models things to be manufactured using a CNC machine or any other machine. So here also Nurbs are the main form of modeling. So in coming classes we will see in detail some useful functions in Nurbs. We will try to create models using curves, then to Nurbs, then convert them to polygon, control Nurb surfaces, control curves. We will see some classes, and again then we will go to polygons. Thanks for watching. If you have any doubts, please comment below. Subscribe us. We will see you in the next class. Thanks for watching. Thank you.